Okay, I'm not 100% positive that this is the only way to do this problem, but my guess is that we're looking for some similar triangles. Here is the original triangle, triangle ABC, isosceles, which means AB is equal to AC. And if AD is to DB as 3 is to 1, then we can represent this distance AD with a 3x and DB with an x. And we'll have the same situation on the other side. I drew this horizontal dotted green line extended to show that this line parallel to the base divides the sides of the triangle into the ratio of 3 to 1. Okay, and now if you extend ray DE or side DE this way and side BC, you could do it the other way too. E could be up in here and you'd have a different situation. But they meet at point F, and because of parallel lines being cut by a transversal, this line DF, alternate interior angles are congruent. That's these two little angles right here. And here at point E, we have two vertical angles. So this triangle right here, DPE, is similar to triangle, and we have to pay attention to the order of the letters, but F corresponds to D, C corresponds to the P, and E corresponds to itself because that's where the vertical angles are. We're given that DE is to EF as 1 is to 3, which, because the triangles are similar by angle, all corresponding sides have the same ratio. So PE to CE must be the same as DE to EF, which is 1/3. And that allows us to make this conclusion right here. 3PE equals 1EC. And also because E is between P and C, at least in this case that I'm demonstrating here, PE plus EC equals X, or PC. And this is the distance X right here, which corresponds to this X over here. So this is X. And if that's true, I can substitute this into here for EC, and I get down to the fact that PE is equal to X over 4. This little segment right here will always be X over 4 if the ratio of DE to EF is 1 to 3. And so if I call this X over 4, I want to find out what the ratio is of AD to AE. AD we've represented with a length of 3x, and AE is this 3x plus this x over 4. So I have this complex fraction to simplify, which I did by multiplying numerator and denominator of the big fraction by 4. I get 12x over 12x plus x. 12x over 13x reduces to 12/13. So I believe that the answer to part A is 12/13. Now I have a feeling for part B that we have to put E up in here somewhere, a different situation. And we maybe get something like this and put F over here. And we're saying that DB is probably equal to BF. That's what makes it isosceles. And then we're supposed to find the ratio of DE to, well, we got E up here now, DE to BC. So I'll leave that to you. Look for the same kind of deal, some similar triangles, so you can use angle, and the fact that corresponding sides of similar triangles are in proportion. There you go. Hope that helped. And if you have any questions, post a comment.